In lesson 8.5, we're going to learn a new method called U-substitution. We use U-substitution when the equation that we're given is not in the form of a quadratic equation. So we're going to learn how to reduce to a quadratic equation when what we're given is not in the form ax squared plus bx plus c equals 0. When this is the case, we need to try using U-substitution in order to reduce the given equation into a quadratic equation. In this case, whenever we're using U-substitution, we're going to first set u equal to something. That value is going to be whatever the b value happens to be attached to in the equation that we are given. You'll see what I mean in the next slide when we do an example. And then we're going to substitute u into the equation. This will create a quadratic equation, so then we can use the quadratic formula from lesson 8.2. That awesome formula that we just got to plug numbers into and get an answer. So if we can let u be substituted in and we can create a quadratic equation, then we can use this quadratic formula and make this a nice simple problem. So let's look at the first example. So the directions say solve for x, but as you can see, we can't solve for x because we have x to the fourth and x to the second. That does not look like this equation here. So we're going to let u equal this value that's next to what we would like to be b. So we're going to say that u equals x squared. So if right down here I write x squared in both of these spots, you can see that x squared to the power of 2 certainly is x to the power of 4, and x squared is obviously x squared. Everything else in the problem stays the same. So our letters A, B, and C haven't changed. Now we're going to substitute u in for every place that we see x squared. So I'm going to rewrite this as u squared minus 9u plus 8 equals 0. Hopefully you see now that this problem looks just like our quadratic equation, ax squared plus bx plus c equals 0. So now we can substitute each of these values in for a, b, and c and solve. So that means that a equals 1, because there's no value in front here, so we always put a 1. B equals -9, and C equals 8. And now we can use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all divided by 2a to solve for u. So instead of solving for x right now, we're solving for u. Plugging in these values, we get -9 plus or minus the square root of -9 squared minus 4 times 1 times 8, all divided by 2 times 1. That's what not x, that's what u equals in this problem. So that means u equals, we can put these two negatives together to make a positive. So we have 9 plus or minus the square root of negative 9 squared, which is 81, minus 4 times 1 times 8 is 32, all divided by 2. And then we get from there u equals 9 plus or minus the square root of 81 minus 32, which is 49, divided by 2. We're going to factor 49, which comes out beautifully as 7. So then we end up with 9, with u equals 9 plus or minus 7 divided by 2. Simplify this actually to two different values. We get 9 plus 7 divided by 2 and 9 minus 7 divided by 2. 9 plus 7 is 16 divided by 2. We get 8, and 9 minus 7 is 2 divided by 2. We get 1. So now we have two values for u. U can equal 8 and 1. But we don't want to know what u equals. We want to know what x equals. At the very beginning, if we go back here, we can see that we said u equals x squared. So over here, I have to say that u also equals x squared. Since we want to know what x equals, we need to say x squared equals 1 and x squared equals 8, since that's what u equaled. And now we need to solve for x. So now we're going to use the rules we learned in Unit 7 to solve for x when x is squared. That just means that we take the square root of both sides. So we get x equals, and remember, whenever we take the square root, we learned in this unit, it's plus or minus the value. The square root of 1 is just 1. So we have these answers here. And then we take the square root of x squared, and we need to factor 8. So we get 2 times 2 times 2. One pair means we can take that out in front, and we have 1, 2 that stays inside the radical sign. Again, it's plus or minus whenever we take the square root of a number, and we have x equals plus or minus 2 radical 2. So in this case, we have 4 possible answers for x. And that makes sense because in this problem we had x to the power of 4. That tells us how many solutions there likely are in the problem. So we have 4 solutions for a polynomial that is to the power of 4. Here's another example. This time, we're going to let u equal whatever, again, is attached to the b value, or what we would like to be our b value. So this is what u is going to equal. So let u equal the square root of x. That means that if we plugged the square root of x in to our general formula, we would put the square root of x here, the square root of x here. The square root of x squared is, sure enough, x. And then this is obviously exactly the same. But instead of the square root of x, we want to write this as u squared. So u is in its place. Minus 3u minus 4 equals 0. Now we're going to solve using the quadratic equation, or the quadratic formula, sorry, because now we have a quadratic equation where a equals 1 B equals -3, and C equals -4. So let's go to the next page and plug those into the quadratic equation. Plugging those values in, we get -3 plus or minus -3 squared minus 4 times 1 times -4, all divided by 2 times 1. Simplify this. Sorry, this is u equals now because we're doing u substitution. Simplify this. Negative is a positive 3 plus or minus -3 squared, which is 9, minus, this time we have a -4 and another -4, so our answer or value down here is actually going to be positive, and we get 4 times 1 times 4 is 16, all divided by 2. U equals 3 plus or minus 9 plus 16 equals the square root of 25, a nice value because the square root of 25 factors beautifully to 5. So we get u equals 3 plus or minus 5 divided by 2. Let's simplify those down to our two u values and then plug them back in. So this becomes two different problems, 3 plus 5 over 2 and 3 minus 5 over 2. We get 8 divided by 2, which is 4. 3 minus 5 is -2 over 2 equals -1. Alright, so we know what our u values are, but we're not interested in u, we want to know what x equals. So we now need to plug these back into what we said let u equal. Let u equal the square root of x. So if u equals 4, it also equals the square root of x. If -1 equals u, then it also equals the square root of x. To solve for x then, we have the square root of x equals 4. We can square both sides, and we get x equals 4 times 4, which is 16. There's one answer. We also have the square root of x equaling -1. Square both sides. Again, we get x on the left, and then we get -1 squared, which is 1. So, x equals 16 and 1. That would be our final answer. We're going to go through a few more examples because they are all slightly different, and I know you're going to see all of these in your homework and on future tests and quizzes. So I want to make sure that you're familiar with all the things that we can let u equal. If you want to try your homework at this point and you feel like this is enough, go for it.